Hello, good morning, Doctor and my fellow friends. This is our Group 7 from Group 7 from Section 21 for subject code SSCE1693 Engineering Mathematics. This is our group member, Chan Lee Seng, Tan Ru Hong, Ng Wai Kit, Aaron Tiong, and Lau Lili. Let's start with introduction by me, Aaron Tiong. Okay. Introduction to system of linear equation. There are few methods for solving system of linear equation, which is by elementary row operation (ERO) and matrix method. For ERO, we shall use Gauss or Gauss-Jordan elimination methods, and for metric method, we will be using inverse matrix and Cramer's rule, which will be explained further on. The system of linear equation with m linear equations and n number can be written as A11 x1 plus A12 x2 and so on, as shown here, and the solution of the equations are real value of x1, x2, x3 until the term xn, which satisfy every equations of the equations shown previously. If the equation previously have no solution, then it is inconsistent and vice versa. The equation will be homogeneous system if bi equal to 0, where I is equal to 1, 2, 3 until n terms. However, for the solution xi equals 0, I equal to 1, 2, 3 until n for homogeneous system is called trivial solution. Let's start with our problem statement. One day, there were 3 students went to a stall to buy some nuggets, hot dog, and wontons. However, the profit earned by the owner does not match with the number of foods.
Hey, I noticed just now, a few students came to my store and some of them stole my nuggets. How can they do this? And I checked CCTV, the first student did this. And I only earned 3 ringgit for first student.
Oh my god, how can he do like that?
Yeah, I know, right?
So how much is the book?
And the second student did this, okay? Let's see, let's see what he did. And the third student, he didn't steal anything, he's very good. He paid me 23 ringgit. It's quite a profit.
So, the first person bought 1 nuggets, 1 wonton, and stole 1 hot dog. However, the second person bought 4 nuggets, stole 3 hot dogs, and 1 wonton. And the third person bought 1 nugget, 1 hot dog, and 2 wontons.
Gauss elimination method. Gauss elimination is a method of solving a linear system by bringing the augmented matrix to an echelon matrix. From the problem statement, we get 3 equations. Let's solve the following system of linear equations by using Gauss elimination method. Step 1. Construct the augmented matrix. Step 2. Using ERO to transform this matrix into the following echelon matrix. Step 3. Solve using batch substitution. Then we can get the solution that x equal to 5, y equal to 4, and z equal to 2. Gauss-Jordan elimination method. Gauss-Jordan elimination is a method of solving a linear system by bringing the augmented matrix to a reduced echelon matrix. Using ERO to transform the echelon matrix that we get just now to reduced echelon matrix. Then we can get the answer directly.
Good morning, Doctor and my fellow friends. My name is Ng Wei Kit, and now I will discuss about the Cramer's rule. First of all, what is the Cramer's rule? Cramer's rule is one of the important methods applied to solve a system of linear equation. In this method, the values of the variables in the system are to be calculated by using the determinants of the matrix. Thus, the Cramer's rule is also known as the determinant method. In order to find the Cramer's rule formula for a 3 times 3 matrix, we need to consider the system of 3 equations with 3 variables. These 3 equations are the example, and we can write it in the form of AS equal to B. The matrix A is the coefficient, matrix S is the variable, and the matrix B is the constant. Next, we let the T become the determinant of matrix A. We can calculate the TS, TY, and TZ by changing it the first column, second column, and third column by the matrix B. If the determinant of A is not equal to 0, then the matrix can be solved by using the Cramer's rule, as shown below. The S can be calculated by using the TS divided by T, for variable Y, TY divided by T, and for variable Z, the TZ divided by T. Based on the situation given before, we know that the S minus Y plus Z is equal to 3, the 4S minus 3Y minus Z is equal to 6, the 3S plus Y plus 2Z is equal to 23. And first, the step 1, we write it in the form of AS equal to B. Then we calculate the determinant of A and we get 19. Since the determinant of A is not equal to 0, so the given system of equation has a unique solution. We can calculate the ds and we get the 95. For dy, we get 76. And finally, we get the dz is 38. And finally, we can calculate the variables x, y, and z. From the calculation before, we know that the d is equal to 19, the ds is equal to 95, and the dy is equal to 76, the dz is equal to 38. According to the Cramer's rule, the s can be calculated by the ds divided by the d, and we get the 5. For variable y, we get 4, and for variable z, we get 2. Thank you.
Hello guys, my name is Chan Lee Seng and my part is inverse metric method. If the determinant of A is not equal to 0 and AX equals to B, so that we can solve the linear equation by multiplying A inverse in both sides in the equation AX equals to B. Then the result simplified to X equals to A inverse multiplied with B. Based on the situation before, the matrix notation is shown as below. For the first step, you should check the determinant of A whether it's 0 or not. When the determinant is equals to 0, stop the calculation because the inverse does not exist, and vice versa. When the determinant is equals to 0, continue to step 2 by using adjoint method or ERO method. Given that the matrix is shown as below, so the determinant we calculate is 19, which is not equals to 0. Therefore, A inverse exists. By using the adjoint method, we must find the cofactor of the matrix. The steps are shown here and we'll get our cofactor matrix by combining all of our cofactors here. To get the adjoint A, we transpose the cofactor matrix of A that is shown as below. Hence, we should substitute the result from step 1 to step 3 into the formula. Then we'll get the answer x equals to 5, y equals to 4, and z equals to 2. After that, we can also get A inverse by using ERO method. We will need to perform ERO until we get new augmented matrix as shown as below. Based on the situation before, the matrix notation is shown as below. By using the ERO method that's shown in above, we obtain that A inverse is this. Therefore, by using the formula x equals to A inverse multiplied with B, we'll get the answer, which is x equals to 5, y equals to 4, and z equals to 2.
Hi, I'm now going to introduce the type of solution that exists in the metric system. There are steps to identify the types of solution. Firstly, we need to calculate the determinant of the matrix equation. If the determinant of the matrix equation is equal to 0, it will have either many solutions or no solutions. If the determinant is not equal to 0, it will only have a unique solution. If the determinant is equal to 0, elementary row operation is used to determine whether it has many solutions or no solutions. Lastly, the row echelon matrix is analyzed if the value of C at the third row as shown in the slide is a non-zero constant, therefore it has no solution. If the value is 0, it will have many solutions. This is an example of a matrix with a unique solution. We have already calculated the determinant and it is not equal to 0 and knew that it has a unique solution. And the equation is being reduced to row echelon matrix by using elementary row operation, and the final answer is as shown in the slide below. After calculating the solution, we will know that x is equal to -6, y is equal to -3, and z is equal to 2. This is an example of a matrix with many solutions. The determinant is calculated and is equal to 0. Therefore, we need to use elementary row operation to determine the type of solution. After the matrix is being reduced to row echelon matrix using elementary row operation, we can observe that the C value in the third row is equal to 0. Hence, it has many solutions. To calculate this, we will need to let Z equal to t, and by using substitution, we will know that x equal to -3 plus 4t, y is equal to 4 minus 3t, and z is equal to t. The reason we need to let z equal to t, which is an unknown, because t will have many possible values, and as a result, this equation will have many different solutions. This is an example of a matrix with no solution. The determinant is equal to 0 and the elementary row operations used to determine the types of solution. After the system of linear equation has been reduced to row echelon matrix by using elementary row operation, we can see that the value of C at the third row is a non-zero value, therefore it has no solution. Lastly, this is a solution to our problem statement. The determinant is equal to 1, hence it has a unique solution. After the system of linear equation has been reduced to row echelon matrix, we can calculate the solution easily. The final solution we will get. Okay, 重新来过这版。Lastly, this is a solution to our problem statement. The determinant is equal to 1, hence it has a unique solution. After the system of linear equation has been reduced to row echelon matrix, we can calculate the solution easily. The final solution we will get is x equal to 5, y equal to 4, and z is equal to 2. That's all. Thank you.
This is the conclusion for our group assignment by me, Aaron Tiong again. Okay. So, solving linear system of equations, there are Gauss elimination method, Gauss-Jordan elimination method, inverse metric method, and also Cramer's rule. So, there are a few types of solution, which is unique solution, many solution, and no solution. Okay. This is our references, which is from the internet, mostly is from this YouTube channel and few YouTube videos here. So, we took from 5 YouTube videos and also from engineering mathematics books. Okay, that is all from us. Thank you.